Bonjour, bonjour et bienvenue. Welcome on the Paris Space Hub. My name is Jules Rancière from the European Space Agency, and today we'll take you on a journey from Earth to low Earth orbit, the Moon and Mars, and then we'll take you back. Don't worry. For this journey, we'll cover the ESA's exploration program, its ambitions, its strategy, but also its challenges. And for this journey, I've got an exceptional crew with me today. Daniel Neunschwander, ESA Director for Human and Robotic Exploration. Angelique van Onbergen, ESA Exploration Scientist, Chief Scientist, sorry, what a cool title. Andreas Mogensen, ESA astronaut and newly appointed head of the astronaut corps of ESA. Orson Sutherland, the project manager, no, what's your title exactly? Mars and Beyond Projects Team Lead, correct?
Exploration Group Lead.
Exploration Group Lead. And Jan-Hendrik Horstmann, ESM Group Lead, that's correct?
Team leader and the program manager.
You're the expert of the European Service module with us today. Thank you so much for being on stage with us today. We'll have the opportunity to take your questions from the floor at the end of this session, but first, let's set the stage a little bit with the participants today. Daniel, let me start with you and with a question about the news. We've been following the news lately, and probably many of you have seen the White House proposal for NASA's budget next year. We've been able to discuss the potential impact on the international exploration programs. What's your analysis of this situation?
Bonjour Paris, good morning to all of you, and welcome to this session. Really happy to be with you here today. I'm not surprised, Jules, that you start with this question. Of course, it's in the head of everybody right now. But we have really to see that we are only at the beginning of a process. There is an announcement by the White House, which was done during the month of May, which potentially would lead to a significant drop of the NASA budget by 24% in average overall. On the other side, there would be a focus on human exploration at the lunar surface and Mars. But it hits us as European Space Agency potentially, and I insist on the potentially, in all the record programs, the International Space Station, Orion ESM, Gateway, Mars Sample Return, and eventually even Rosalind Franklin. So in such a situation, what matters is that you stay cool-headed. You stay cool-headed, you focus on your work. We discussed with our member states last week about it. But the project teams have just to continue the work according to what has been decided. But cool-headed does not mean that you are not preparing. And what we are doing is that we are a reliable partner. We have proven that since decades. We celebrated yesterday nicely the 15 years of the European Space Agency. We have delivered over 5 decades to our international partners. We will continue to do so. We'll stay along with the US as long as they stay along with us. And we will be ready if there would be a decision, and we are not yet there, on our side to take our European responsibility, and it is part of our strategy to increase the autonomy in this context, autonomy for more robustness in cooperation.
When you speak about robustness in cooperation there, does it mean, and that's a question a lot of people are asking right now, does it mean Europe is reconsidering the level of reliance on the US at the moment?
Again, we are a reliable partner, and we expect that our partners do the same. Now, should we change our attitude? I don't think so. I think we just have to be ready to take our responsibility. We are challenged. Okay, that's the case. And we are looking now project by project what it means, what are the options which we can introduce to that. And robustness in cooperation means exactly that, that we are not walking away. We will continue to work with the US. The US are a strategic and long-standing partner. Of course, we will look also for additional partners. I just recall that We signed last month with India a joint statement on human spaceflight cooperation. We signed earlier this year with Japan a joint statement on robotic cooperation on the lunar surface and on Mars. We are looking into our portfolio of partnerships, but with whomever we work, we'll continue to deliver. We keep the options, and I'm sure we will also go through new projects one day with the US.
Thank you, Daniel. Now, speaking about human space flight, you, Andreas, you have the newly appointed title of Human Exploration Group Leader. It means that you are heading the human space flight activities at the European Space Agency. Today, that happens in LEO, and we are seeing a fast evolving environment in low Earth orbit lately, with commercial actors joining the game. What is ESA's position towards this post-ISS era?
Well, we're seeing a very exciting development in low Earth orbit. Together with many of our international partners, we are seeing a resurgence of commercial actors as well. In particular, on the ISS, we have commercial missions. I had the pleasure of welcoming Axiom 3 during my last mission, where we also had my ESA colleague, Markus Wandt from Sweden, joining our mission for 2.5 weeks. And this was a great opportunity to extend the partnership on the ISS. And the hope is that when the ISS is eventually retired in the next 5-6 years, that our collaboration with these commercial entities will lead to a commercial space station in low Earth orbit, because we would really like to continue to be able to perform science and technology development in low Earth orbit. We are really doing a lot of incredible, interesting science in or on the ISS at the moment, and we would like the opportunity to continue that in the future also, while focusing on destinations further out in the space, like the moon. And so the idea is to allow commercial companies to take over the operations of a commercial space station, and then ESA and other international space agencies could send their astronauts to a commercial space station to conduct science and technology development. And we have several partnerships in the pipeline. Just yesterday, ESA signed a memorandum of understanding with Blue Origin and Thales Alenia Space on the orbital reef. And so we are really exploring the possibilities of how we can cooperate, not just as a user and as a paying customer, but also as a partner with many of these commercial entities. You know, can we deliver hardware to their space station? What will be the role of our astronauts, and so on and so forth. So a very, very exciting future where we hope to be able to continue conducting science in low Earth orbit, while at the same time beginning to transition to deep space missions as well.
And those commercial partners are present already in human space flight. We've spoken yesterday with Commissioner Kubilius and Sławomir Szymanski, your colleague of ESA. He will fly on an Axiom flight very soon to the ISS. Is it something that ESA is interested to use more and more, as well as long-duration space flights?
Certainly. You mentioned my colleague Sławomir, who is currently in quarantine in Florida, waiting imminent launch on Axiom 4. An incredibly exciting time for Sławomir and, of course, Poland and ESA as a whole. You know, I have to say, ESA was very, very foresighted a few years ago when we decided to select what we call the Reserve Astronaut Corps. The idea behind that was to extend the opportunities for our member states, our 23 member states, to have citizens of their countries, astronauts from their countries, also conduct science and technology in space. And that's what we're seeing today. Our member states, through the Reserve Astronaut Corps, have a chance to have their astronauts fly in space as well. And these are very exciting missions because it is a focused scientific mission where you get to use 100% of your time on conducting science. You know, for us astronauts who are up there for 6 months at a time, like my last mission, a lot of our time is spent on maintaining, running, operating, and repairing the International Space Station. But these shorter duration missions are focused entirely on science and technology development, and it really gives a huge boost in our utilization of the space station.
And we can trust your word when you say that. Your first flight was one of these fully packed 15 days space flights, so you know the two sides of the coin here. Angelique, we said we'll speak about the challenges. Now, Andreas mentioned the importance of doing science in microgravity in low Earth orbit. As a chief scientist, today you're responsible for the ESA science we do on the International Space Station. Now, it's been mentioned already, the space station won't be here forever. 5 years, 6 years maybe. And then we will rely on other platforms, I'm guessing. How do you, or how do we, ensure continuity of science interest in space?
Yeah, so I think within the exploration directorates we have a bit of a unique mandate when it comes to science, because on the one hand we do missions, for example, to the International Space Station, but eventually also to Moon and Mars, where we can enable science, where we can make use of the platforms that we have and open them up for a wider science community. That's really the science that allows us to, let's say, answer fundamental questions about the universe, the principal matters about search of life on other planets. So we are a little bit in a unique position that we can leverage these activities, these missions that we do to, let's say, also cater to that very important questions. On the one hand, of course, as an exploration directorate, in particularly also focusing on human spaceflight, we have knowledge gaps that we need to close in order to be able to propel further. So if we really want to make sure that eventually we will be able to bring Europeans, for example, to the Martian surface, we need to be able to close knowledge gaps, to do technology de-risking, and that's also why, for example, missions to the ISS are now so important. The ISS is really, for us, from a scientific perspective, a luxury position. We have a lot of equipment available, we have furnaces, we have facilities, and even though it's very complex machinery, it works quite well, and we can really push through a lot of science. That obviously will change as we move into a new paradigm, but that also means that there will be new opportunities to work with other partners, to work more closely with industry, and also to work more on a commercial basis. So what our member states have also asked us, of course, is to explore that. That's also something that we are ramping up quite actively now in our scientific activities, and where we want to also diversify the platforms that we have. We can do physical sciences, biology, biotechnology. We don't always need to have a crewed platform for that. We can go to free flyers. That's something that we are assessing now very strongly. And on the other hand, of course, we have the astronauts and the crew, and we need them as test subjects. I'm sorry, Andreas, but that's in the end the case. And this is also very important for us. So I think moving forward, what we will see is really a diversification of the platforms that we work on, and try to leverage each platform for the benefits it can bring.
I'm glad you said test subjects, because yesterday we heard about guinea pigs. I think that's a more appropriate word. Thank you, Angelique. Jan-Henrik, let's go from low Earth orbit to the moon. This is your focus at the moment. You are in charge of the European Service Module at ESA, which is basically what will power the astronaut who will go back to the moon and bring them safely back home as part of Artemis 2. ESA has already delivered 3 of those ISMs. The first one on Artemis 1, an uncrewed mission to the moon and back. Artemis 2 is now ready to launch, and we've delivered the ESM-3 as well. Can you unpack this a little bit for us? What's the core of your work?
Yes, with pleasure. So as Daniel has said it, we are a reliable partner to NASA, and as such we have demonstrated an ESM performance on Artemis 1 in 2022 that outperformed our expectations and I think NASA's expectations as well. So we've been able to sneak in new objectives throughout the mission because it was performing so well. And with that, we have all the good hopes now for Artemis 2. As you said, NASA is preparing the mission for an early launch in 2026. We are supporting NASA to get ready. We are ready and all excited that we can now for the first time fly astronauts on our vehicle. ESM-2 has the life support systems included that we didn't fly yet on Artemis 1 that are now on the ESM-2. So we are all excited to see how it performs with astronauts, with crew on board. ESM-3 was delivered last year and is being processed at the Kennedy Space Center right now, also to prepare Artemis 3 then, to be ready for NASA to fly that mission. And even Artemis 4, we are about to deliver an ESM-4 at the end of this year. And to be very clear, again, we are a reliable partner to NASA. We are full speed ahead to deliver ESM-4. We are processing the ESM-5, ESM-6 in Europe to be ready when NASA needs them. We need to remember, I think, these budget proposals, yes, they may have a big impact on the Artemis program, on the ESM, on our colleagues in the Gateway program around the moon. Nevertheless, we are quite certain that the budget is a proposal that can evolve, and we want to be ready for what it evolves to, right? So that can be maintaining the missions, that can be having ESMs ready as backups in case something goes wrong. You never know. Space always has been hard. Space is hard today. Human spaceflight even more, so we want to be prepared.
And to stay around the moon program, Daniel, I want to ask you about something that you, in the audience, you might have seen on the ESA stand just next door, a mock-up of the Argonaut. The Argonaut is an exciting piece of hardware. That's a lunar lander, as far as I understand at least. Daniel, could you tell us a little bit more about this aspect of the program that might be a little bit less known to the general public?
It's time to learn about then. For sure, it's a very exciting project because it's about our European capability to come to the lunar surface. And this is absolutely strategic. And I think it's a good example also of what we just discussed a couple of minutes ago. When we speak about more autonomy and resilience in the cooperation, it's exactly projects like Argonaut. Why? Because on the one hand, you can use this Argonaut lunar lander as a piece in an architecture of international partners, Artemis, for example, and bring your piece as Europeans to the table. But you can also use Argonaut for our own European roadmap, and that's exactly what it is about. So we have a lunar roadmap. We want to understand and demonstrate by the end of this decade with demonstration missions. We want to build our capabilities until the mid of the next decade with Argonauts, plural, so it will be more than one mission. And then we want to live and operate at the surface of the moon as of the mid of the next decade. And this is exactly the type of project you need, which is at the center of the implementation of such a roadmap. So I share your statement, an exciting project.
And when you speak about autonomy, more autonomy with this project, what about the launch? Do you plan to launch this with any type of launcher?
Well, if we go the European way, we'll launch it from our European spaceport in French Guiana on board of an Ariane 64. I invite all our colleagues to make sure that the Ariane 64 will be there. I'm very confident we need it at the right performance. I know a lot of colleagues who worked hard to make it happen. We'll see the qualification flight of Ariane 64 probably end of this year, early next year. And by 2031, when we will have our first Argonaut mission, Ariane 64 will be the workhorse who will deliver Europe to the moon.
And today this Argonaut is a cargo, right? Delivers 1.7 tons of cargo on the surface of the moon, is that correct? Or
We will start with 1.5
1.5.
tons and then increase it to 1.8 in an incremental way.
Okay. And before Andy asks you the question, I'll ask it. Is he going to bring his astronauts to the moon at some point?
Well, I'm less than 1.5 tons, so hopefully.
Is that in the plans, Daniel? Is that way open, or is it closed at the moment, this road?
It's clear that in Europe, we stand for responsible, sustained, and sustainable exploration. These are three keywords. So we are not going to the surface, to the moon, to bring a flag there. That's not the point. We want to understand. When I say we want to understand, we want to conduct science. We want to open up for an upcoming, and I insist on upcoming, but upcoming lunar economy. I mean, if you really want to reap the benefits of these activities, you must live and operate from the lunar surface. So I'm very happy to learn that Andy has some margin, and we will make it.
That's good perspectives. Let's travel further even to Mars with you, Austin. Mars, the least I can say is that it's fashionable at the moment. We've been hearing a lot about the importance of going to Mars and the ambitions of the US going to Mars. Declarations from Donald Trump or Elon Musk have been very clear about their ambition to bring humans to Mars. You as the expert on Mars, the lead on the Mars project at ESA, can you tell us a little bit about the European approach to exploration of Mars?
Well, ESA has been at Mars for over 2 decades. Let's remember that. We've got Mars Express and TGO, and we're there because we want to understand how the planet was formed. We want to understand better its environment, and maybe we might find extant life or remnants of previous life. So it's really one of the key goals of our program. Is life beyond the Earth? Now, of course, those are important scientific objectives, but we also sit within a human exploration setting. And so the Explore 2040 strategy is very clear about this. We have a horizon goal for Europeans to be on the surface of Mars in the late 40s. But that's not something that you just click your fingers and do from one day to the next. It's not just a rocket ship that'll take you there. There is really a huge amount of background work that needs to be done. And part of that is the scientific research to understand the environment that you're going to. Where should you go? Why should you go there? Is the environment you're going to safe for the astronauts that will fly there? What types of systems can we put together to keep them safe? But it's also about developing the life support systems that you'll need there, the in-situ resource utilization that astronauts might one day need to be able to use to sustain life on the surface, and then eventually return home. Because flying out to Mars, you don't bring the fuel and then fly all the way home. You have to be able to make your fuel out there to come back home. So there's lots of reasons for us to be sustaining our presence at Mars, both in orbit and on the surface.
And we spoke about the potential, the possible cuts on the NASA side. We do a lot of cooperation with NASA on our Mars projects. Again, what is the European approach to this at the moment as far as Mars is concerned?
So Europe has its own sovereign Mars program, and let's start with that. So if we look at the 2 main streams that we have an orbital stream and a landing stream, okay? And the orbital stream, we have a concept called Lightship. Lightship is an electric propulsion tug that will bring passenger spacecraft out to Mars, drop them off into a determined orbit, whatever that might need to be. By the way, it could be one or several spacecraft. It could be large spacecraft, it can be small, it can be CubeSats. We can do a range of spacecraft with the Lightship space tug. So after having dropped off the spacecraft in its operational orbit, we then spiral the tug up to what we call the Marconi orbit, which is roughly 6,000 kilometers above the surface. And we start a service of communications, navigation, and actually also science from that higher orbit. And the idea is that with every new mission, every new science orbiter that you fly out, you put one new node in a constellation of satellites to give you global coverage around Mars so that you have communications, navigation, and science, which you should understand as things like meteorology from that orbit. Now, why is this important? It's important for 2 extremely important reasons. The first is all about the science. As we move into next generation science at Mars, we have to think of things like SAR, high-resolution imagery, but not just of 4% of the planet, but the full planet spectrum. You create a huge amount of data. And that part is easy to do. Generating the data is easy. The difficult part is getting it back to the Earth. And with a lightship and the new communication systems that we'll have on board, we'll be able to boost up the comms capability and bring that data back to the Earth for the science community to work with and our exploration scientists and engineers to work on future programs. That's point number one. Point number two is that if we really do believe that we're going to Mars with humans, and that is in our strategy, and we do believe that eventually it will happen, you will need infrastructure to do that. And part of that infrastructure is making sure that the astronauts that are down on the surface can communicate with whoever they need to, whether that's on the surface of Mars, whether it's a mothership in orbit, or whether it's with the Earth. So again, this idea of a constellation giving you global coverage solves that problem. But your astronauts and the equipment that we'll have, robots, all the rest, also need to have very precise geospatial understanding where they are on the surface. So navigation, and here we should think about GNSS-style navigation, Galileo-style navigation for Mars. Okay? And then the third element is the meteorology, understanding the weather patterns. If you're an astronaut down on the surface, you want to know that there's a dust storm coming. You want to know that you can protect yourself and you can get all your equipment safe. So those are three elements that are there for the future of our human exploration program. Now that's the orbital program, but we also need to have a landing platform. Now we were talking before about Argonaut for the moon, but for Mars it's very similar. You need to have logistics capabilities on the surface of Mars. So Rosalind Franklin is our next big mission to the surface of Mars. That mission is all about getting a rover down and discovering life, potentially discovering life at Mars. But it's also about learning to land on the surface of Mars reliably. And our next lander, MEDAL, will go one step further, a little bit more precise in the landing, and then we will build on our capability, ever more precise, ever heavier with the landers, such that eventually when we do have these crewed missions, we can bring very significant mass to the surface for logistics support, whatever that may be.
It's easy to understand how precision is a key element when you land on Mars. If I look at Andy, I'm sure you prefer to not have a walk of 20 days to get your food, for example, or other supplies. So that's built in the strategy of the Mars exploration, right?
Absolutely it is. Yeah.
Angelique, I'm just trying to imagine what goes on in your head when you hear about astronauts on Mars, astronauts on the moon, and all the new possibilities that it opens for science as well, because we haven't spoken about science on the moon and Mars. What does it change for you in terms of the perspectives that it offers for scientists and for you as a chief scientist?
Yeah. Well, I think within our program, we are very lucky to have a very multidisciplinary science element. We really cover fundamental physics, biology, human physiology, psychology, geology, planetary sciences. So we have a very broad realm, and I think that's of course also because we have this combination of human and robotic exploration, which makes it quite distinct, I think, and makes it quite interesting from that perspective. When we think, of course, about Moon and Mars, Orson already highlighted some of the key features there, but there's a lot of key knowledge gaps that we haven't answered. What are the environments like? What does it mean when we bring humans there or when we bring missions there? What does it mean for the environments as well? Not only what do the environments do to our crew or to our, let's say, spacecraft and materials, but also how do we change those environments and how can we minimize not disrupting those pristine environments too much with our activities. Orson talked also about in situ resources. This is, of course, a very important element. If we want to eventually bring humans to Mars, we need to understand what resources are available, how can we get to them, can we use them? So there's a lot of different steps that range from fundamental knowledge to eventually applications for crewed missions. So when we think about Moon and Mars, I think generally the science we do is very different from what we do, for example, in LEO and on the ISS. So I would say it's really focused on answering those key knowledge gaps that will allow us eventually to explore, that will drive also our mission planning, that will help us eventually also to keep our crew as safe as possible, not only during the mission, but also when they come back. And I think it's this interesting element that we have within the program, that we have this very transversal ranging from even ground, because we do a lot of ground research, to low Earth orbit, eventually Moon and Mars. And as mentioned before, we have a unique opportunity not only to try and answer some of our key knowledge gaps for exploration, but also to cater to a big science community in Europe that is interested in some of these fundamental questions.
Thank you, Angelique. Daniel, let's come back to Earth, because we speak about a strategy, we speak about ambition, but all these decisions concerning those ambitions will be taken here on Earth. So if we speak about the strategy, how would you describe what we see on the screen, your exploration strategy for the European Space Agency? How would you summarize it?
To summarize it, by destination, in low Earth orbit, have a continuous presence and use of this marvelous opportunity close to Earth, a couple of hundreds of kilometers. Second, building up capabilities at the lunar surface around the moon, but then lunar surface, in order, again, to live and operate there. And third, at Mars, continue our robotic excellence, which we have built up over years already, but strengthen them in order to go towards the horizon goal, which, of course, is to bring Europeans also to Mars. But let me add a personal note, because it's great to have this type of strategy, and we are looking for decisions. But as on life on Earth as well, nothing is carved in stone. You need to be able to adapt. And it's even more true in space exploration, because we operate in a really harsh environment. So we need to be able to adapt. We need to have a clear plan, but also the flexibility and the pace of really coping with the challenges we face day to day. And we have to make the link with the very first question you asked me. We need to also to have a certain European resilience. And I would like to conclude by thanking my team, because they demonstrate this European resilience day by day.
Thank you very much, Daniel. Thank you for your time. All of you will now open the floor to questions. And yes, we have already a first question here. Do we have somebody with a microphone? Yes, the microphone is coming to you.
Hello, Antoine Meunier, lachroniquespatiale.com. You mentioned the uncertainties in America. What are the possible scenarios to reuse some key elements, such as the elements of the gateway station, and probably some of the ESM, next ESM, ESM4 to ESM6?
Well, let me start, and then my colleagues can come in, of course. So thank you for the question, Antoine. We discussed this with our member states last week, and again, and this is really important, point number one, we will continue to deliver. Point number two, the reply to your question depends a lot project by project, so it's not one generic question. But of course, when we say that we will be ready to take decisions, we are of course looking into a number of options. When it comes to the gateway, the partners of the gateway, who are the US, Japan, Canada, ESA, but also UAE recently, we are discussing quite openly a number of options. And from the European side, we will first and above all assess the options which are developed among the partners, which does not prevent us to think. It does not prevent us to think, to propose, and at the end really bring to the table alternatives also for Europe. And we will just maximize the skills we have. We have a very strong position on the gateway. And there are options in cislunar, and there are options which are closer to Earth as well. Same applies to the European service module. I think it was nicely said. We are absolutely on the critical path. There's no American astronaut flying back to the moon without the European service module. That's a very important point to be highlighted first. And it's a marvelous vehicle. Jan-Hendrik just underlined how we overperformed as well at the beginning. So I think that's a good point. And we will just build on these capabilities. You can do so much with a vehicle like the European Service Module, which, by the way, is not only propulsion, it also feeds, and here again, I'm sure Andy will like it because it provides some oxygen, some water, the type of things the astronauts like.
There was another question next to you, Antoine.
Hello. Hello. First of all, thank you for your amazing perspective in your talk. I'd like to ask you, what are the plans of the space agencies to prevent bringing the existing conflicts of our planet to other planets or space objects? Thank you.
Well, let me delegate this one. Come on, Andy, that's for you.
Management decision.
Yeah, I mean, it's very clear that there is, certainly amongst astronauts, a very strong sense of camaraderie. And we typically say that, you know, when we launch into space, we launch as humans, as ambassadors for humanity. We are in space working to achieve the same goals. We have the same dreams. And we are really collaborating together to achieve those dreams. So at least for the astronauts, we see ourselves as leaving our nationalities behind and going into space as humans. But you know, certainly I think when we talk about developing a space economy and a cislunar economy, where private companies are going to potentially play a significant role, there's also a need for a regulatory framework. Who has rights to use resources on the moon? I mean, these are open questions. You know, one possibility certainly is that we treat objects in space like we do Antarctica, where it's you know, no one has a right to claim or to use resources, but it's an area where we can all collaborate on doing science and exploration. But exactly how that framework is developed, the future will tell. It's certainly interesting to see that space law is becoming a bigger and bigger subject. We have space lawyers at ESA as well, and this is one of the questions that they're also very much working on.
Thank you, Andy. There's another question. There, we have two questions. Jeff first, and then there's one there.
Hi, Jeff Faust of Space News. As ESA looks to the post-ISS future and use of commercial space stations, what are things that you would like to be able to do on commercial space stations that you're not able to do now on ISS in terms of research activities, technology demonstrations, or just the types of crews that you would be able to have on board these commercial stations?
Well, let me start, but then I also would like that we have the utilization aspect coming in here. So first and above all, as mentioned before, we want to have continuity of our presence and utilization in low Earth orbit. And CLDs are potential platforms who could enable the implementation of this objective. Having said that, from the European side, we are definitely looking into the possibilities to have multiple astronaut flights, and I'm quite keen to see what these actors will propose as possibilities to conclude multi-flight agreements. It's not about one mission, but really a batch of missions. Number two, we would like to secure our scientific activities, and Angelique will detail it in a minute, but that we really go through early utilization, and this needs to be prepared now, meaning before the full retirement of ISS. And third, and that is also really important, Jeff, you speak about CLDs. You assume these are US CLDs. I assume. You can assume from my side that I would like to see a strong European industry presence into that, and we will, from the European Space Agency, support the projects which have a strong European share into it. Angelique.
Yes, maybe to add, I think with the ISS on the science side, we've been a bit spoiled, as I mentioned before. We have a lot, let's say, at our availability, either because we've built it ourselves and delivered it, or because we can work with international partners to get access to their facilities. When we think about a CLD framework, I don't think there's necessarily a lot of science we can do that we haven't been able to do on the ISS. What I will say, though, is that because we will need to diversify much more, we can tailor much better the science we do on which platform and to really optimize then. Because, of course, the ISS is a very big system. It's regulated, or let's say there are certain boundary conditions, for example, the orbit it flies or the altitude. By diversifying the platforms in, let's say, a commercial setting, we could probably tailor a little bit more the science we do and try to get more out of that. As somebody who has a background in human physiology, I think one of my key focus areas, and of course also for the directorate as a human spaceflight directorate, is indeed how are we going to get sufficient test subjects? And again, I'm sorry, Andrew, to keep referring to the astronauts like that, but I think this is also very important. We know that commercial platforms will bring also opportunities there. We might have shorter missions, more crew, more, let's say, diverse audience of crew, which is also important to get the science behind that. The biggest question mark right now will be indeed longer term missions. How can we enable that? Because that's critically important. And there, of course, we will try to work also with international partners, with commercial providers, and try to supplement also research we can do on Earth to try and make it as complementary as possible.
Thank you, Angelique. There was a question here, Stefan.
Yes, Stefan Berensky from Aerospatium. I'm really happy that we have astronauts and scientists on the same panel and that we discuss the Antarctica status, because there is one thing that, well, when we talk about Mars, I hear science. When we talk about astronauts on Mars, I hear contamination. And I know that there is the COSPAR, which has a policy for planetary protection, which works both ways. And recently, with the way the White House and NASA has been discussing man on Mars, we see they don't care. They don't care at all. Do we care in Europe? Is COSPAR part of the planetary protection, part of what we think? Could we be the only adult on Earth about that? I want to have your advice, please.
Thank you, great question. And what I will respond immediately is yes, COSPAR is at the heart, and planetary protection is at the heart of ESA's exploration strategy, and in particular for Mars, we take it very seriously, both forwards and backwards planetary protection. It's an active area of research, how we can do a better job. But one thing that is extremely important is as we do go more and more to Mars, to the surface, that we ensure that we do so in a responsible way. These are pristine scientific environments that we want to preserve as much as possible. And of course, as we do that, we need to understand both the environment. So our science strategy for Mars is based around that, understanding the environment. What is T0? What is it that we're protecting? And then as we explore more and have more presence on the surface, how is our presence changing that environment? It's a very important part of our overall strategy.
Thank you, Orson. Any other question from the panel? Or from the audience, sorry? Here. Antoine, here, the mic comes to you.
Thank you. Sorry, back to my first question. I was not very clear. For the... sorry. Excusez-moi, je vais la faire en français. Pour revenir à ma question précédente, est-ce que dans les scénarios que j'imagine vous explorez dans l'hypothèse de l'annulation de la Gateway, est-ce que les éléments critiques créés en Europe pourraient par exemple être réutilisés pour une station en orbite LEO?
So could I just translate? You're asking if in the case of a cancellation of the Gateway station, could the European elements that we provide to the Gateway, the contributions of ESA, be utilized for another project such as a LEO space station? That's your question?
The question comes much more precise in French, Antoine, but all good. Yes, we are looking into all options, to be clear. And of course, a repurposing of the gateway elements in low Earth orbit is an option. But it will be a decision of our member states. And I think the key topic again is that today we have a clear path on gateway. I recall that if we speak to gateway, that there is a process ongoing in the US, and you may have seen that Congress and Senate will deliberate also on a reconciliation budget. There is a proposal on gateway. So let's take the steps in the right sequence. So this will be point number one. Point number two will be the options to be discussed among partners of gateway, as underlined before. And third, of course, we would not do our job if we would not assess every potential option to maximize the return of investment from our member states. Our member states took a strong stand on gateway. We produce IHAB, which is a habitation module. We produce ERM XL, which is a refueling module, and by the way, provides also very nice view to the lunar surface. It's why we call it, by the way, lunar view. And we have also the HLCS, which is a telecom relay, so we call it lunar link. And with that, you see that we are strongly present. Member states invested heavily, and we want to make the best out of this investment.
Thank you, Daniel. Thank you, Antoine. Any more questions from the floor? I don't see any hands. One more? If not, well, thank you so much, everyone, for spending the time with us to unpack the strategy of exploration for the European Space Agency. I wish you a very nice day on Le Bourget in the Paris Space Hub, and don't hesitate to visit us on the stands of the European Space Agency. Have a good day, bonne journée. Merci beaucoup.